Hello, hello. My topic.
Hello. Good afternoon, everyone. Welcome to International Conference on Advanced in Science, Engineering and Technology. I, Farhazia, Assistant Professor from Department of Computer Application, honored to be your moderator for today's session. We are delighted to have you here with us, what promises to be an enlightening and engaging event. Today, we have gathered experts from computer science and engineering and to share their insights and experiences. Now, without further ado, let's get started. It's my pleasure to introduce session chair for today. So we have Dr. Mohammad Siddiq sir from Majan University. He is the head of Registry System and Examination, Majan University College, Muscat, Oman. We also have Dr. Santosh Kumar, Associate Professor, School of Computing Science and Engineering, Galgotia University, Noida. Please join me in welcoming Dr. Mohammad Siddiq and Dr. Santosh Kumar leading this session. I want to extend a warm welcome to our participants joining us both in person and online. We are excited to have such a diverse and engaged audience. We have an excellent lineup of papers and authors for today's session. Our first author is Mrs. Gausia Yasmin. Her paper title is Role of Image Processing and Machine Learning Technique in Detection of Crop Stress and Crop Disease, an overview. The paper ID is 39. Ma'am, please.
Santosh sir? Santosh sir?
Yes, sir. Good afternoon, sir.
Good afternoon, sir. Sir, are we audible
Yes, sir.
clearly? Okay,
Clearly,
sir.
sir.
So can we start the session?
Sure, sir. Start.
Okay, thank you so much, sir.
Welcome, sir.
Good afternoon, everyone. Myself, Gausia Yasmin, research scholar from a Department of Computer Application, Integral University, also serving this university since 2018. The topic of my paper is role of image processing and machine learning techniques in detection of crop stress and crop diseases, an overview. In this paper, we have given an overview after extensive literature review related to image processing, precision agriculture, and machine learning, that how involvement of image processing with machine learning has gradually exceeded in early detection of crop stress like abiotic and biotic, and helping in improvement of crop health. In the coming PPT, we will be discussing about the role and importance of image processing and machine learning, and how image processing and machine learning has been used to overcome different kinds of crop stress and early detection of crop diseases. What kind of crop stress can be like biotic and abiotic, and also how machine learning algorithms has helped in early detection of disease, and the role of machine learning and image processing with their future scope. As we all know, India's agriculture sector relies on 70% of the population on agriculture, making it crucial to identify crop stress and diseases to prevent losses. Image processing based crop stress indicators after high spatial resolution, low cost, and short turnaround times. This study discusses advancements in agriculture, stress monitoring, and disease decisioning, challenges faced, and future research needs. In this slide, I have given an overview through a graph in which we can observe various crops on which different kinds of machine learning algorithms have been applied for detection of crop stress as well as crop diseases like crop water stress index, artificial neural networks, SVM, regression, ensemble learning, evolutionary algorithms, and other spectral indices like NDVI, NDWI, AFID index. So this study reviews crop stress detection approaches for various crops worldwide using different image processing techniques and machine learning algorithms to predict yield conditions and plant irrigation scheduling. Image processing. Image processing, sub-part of signal processing through which important information can be extracted from various images using its properties. The collection of images can be done by using satellite images as well as UAV like unmanned aerial vehicles. Satellite images, as I am a research scholar, I am also working on satellite images which has been extracted using Sentinel-2 by Copernicus browser. These images cover a vast area and a large number of data sets can be extracted from them. These images helps in crop monitoring, yield prediction, pest control, crop diseases, and various kind of tools and techniques have been provided by using such techniques. These techniques helps in a crucial aspect of agriculture, enabling early detection of pests and diseases, optimizing resource use and promoting sustainable practices. Crop stress. The next topic is crop stress. As I have discussed that crop stress can be detected using image processing. Crop stress can be of two types like abiotic stress. Abiotic stress covers high temperature, cold stress, water deficiency, soil salinity, and biotic stress covers insect, weed, plants, other plants, fungi, bacteria, fungal infections. Such kind of stress comes under crop stress. These are the various crop monitoring indices which have been used or which have been applied to detect crop stress like NDVI, NDWI. Such kind of indices have been used to detect water deficiency or check soil moisture. AFID index has been used to detect biotic stress. Other indices as well has contributed in understanding and detection of various kind of stress and diseases. Role of machine learning. As we all know that machine learning, a part of artificial intelligence, is popular. Its algorithms like support vector machine, decision tree, random forest, boosted decision tree, artificial neural networks. Such kind of algorithms have been boosted and help in early detection of various kind of crops diseases as well as crop stress. Supervised learning models are trained using data sets which can be termed as ground truth. Cropland cross Wuhan UAV borne hyperspectral image, Indian pines and salinas are the few names of data sets which have been used in various research articles. These are the few crops. Data has been collected by through various literature surveys where I have mentioned different crops, the machine learning algorithms used on those crops, and the kind of disease detected through those algorithms, and the efficiency or accuracy which have been achieved by applying those algorithms. This is the process through which machine learning can be used to detect diseases. Like the first step is classification, next is object detection, and through that we discover various kind of the data which we want to collect. At last, the future of farming relies heavily on advanced technologies like machine learning, RSGIS, and UAV. The integration of machine learning and deep learning techniques in agriculture for disease detection has significantly improved accuracy and efficiency. That's all. Thank you.
Can I ask a question?
Yes, sir.
You mentioned spectral indices, yes? Many types of special indices like NDVI, NDWI. Why do we need all of them? If you can go with one or two, why did you list so many of them?
Sir, I have listed so many of them because during after reading various literatures, I have discovered, as I am doing research also, so in that research process, I have done literature review for my research article. So while going through that, I have discovered that these many indices have been used and are utilized for detecting several kind of stress in crops.
Yeah, just one more question to clarify. You said ML algorithms are being used for various crops and different types of detection systems. Which particular ML algorithm do you prefer for identifying the crop diseases? Exactly what according to your study?
Sir, actually, till date, I have not done that part in my research. I have done just literature review and collection of images, and NDVI, NDWI, and GNDVI. I have completed that much of research. So in future, in the coming next RDC, I will be using various machine learning algorithms, and according to the situation which will suit, I will.
Sure. Just one suggestion before
Yes,
we
sir.
close. You need to look at the accuracy percentages. Like you have one of the accuracy was shown in your slide as 79%.
Yes,
so you
sir.
need to look for higher accuracy when you work on that.
Sure,
Yeah.
sir.
Thank you very much.
Thank you, sir. Thank you so much.
Santosh sir, do you have any question to ask?
Yes, sir. I have one question. What is the conclusion of this literature survey?
Sir, the conclusion of this literature survey is that we still need more accuracy to be achieved for early detection of various crop diseases, or in detection of crop stress like drought stress or the extreme temperature. Like gradually the environment is changing, we are facing extreme hot or extreme cold, so we have not done yet any kind of such research where crop condition has been tested under extreme heat or extreme cold. Like this year the winters was extreme, which was very bad
No,
for
no.
few crops,
Wait,
so
wait.
I'll be using
If
that.
you are writing the something research paper, literature survey, analytical study, anything
Yes,
else,
yes,
just
sir.
summarize your work. There are many algorithms working on these fields also. So if you are working this literature survey paper, what is the your results? What is your findings?
Sir, my finding is that I will be working on drought stress for the coming session, and I have collected data, or I am collecting data for the drought stress as well as the flood stress, which in the coming months, the area where I am researching
I
used
am
to
not
suffer.
asking. I am not asking for your future planning. I am asking to these papers only. If you are presenting something, what is the conclusion? Actually, the implementation is not your side. These
Yes,
works, these accuracy of other authors. Yes or no?
yes, yes, sir,
So
yes.
just you write it. Let's say you have the 5 algorithms, 5 papers. One is 90% accuracy, another is 80%,
Yes,
70%, 75%. Then
yes.
conclude is which one is best in these 5 algorithms. That is the more effective, as sir suggest in previous
Sir,
my from that side.
actually,
Yes.
actually, So actually, the algorithms were for different kinds of crops. So the particular algo was suited for particular crop, not like SVM is not done on every kind of crop. So maybe I'll be thinking that for wheat, cotton, and maize, to pick one algo and test it on different crops and then check its accuracy. So that's the conclusion I want to draw.
And you write the crop diseases. So crop diseases, many types of crops are there, under soil, out soil. How you will decide it?
Sir, actually, I have not done that much research. My research will be coming in the coming days, so I'll be working on
Okay.
that. Thank you,
Okay.
sir.
The last question is that you write in PPT high precision. What do you mean by high precision?
Sorry, sir.
In slide, you write that high precision.
Yes, sir. So high precision means that to attain that the amount of research which has been done yet to exceed that limit.
Okay. This from my side. Okay.
Thank you, sir. Thank you.
Thank you so much, Santosh sir, for the questions. And next, I invite Ms. Pooja Sharma. His paper ID is 57, and his paper title is An Analysis of Classification Algorithms for the Identification of Urban Area by Using Satellite Images. Pooja, are you there?
Yes, sir. Yes, sir.
Can you share your screen?
Yes, sir. Just a minute.
Okay.
Sir, am I audible?
Yeah, you are audible, but your screen is still in a minimize mode. Can you maximize the mode?
Yes, sir. Just
You can share the entire window, not the screen. The window, yes. You open your PPT. Just open your PPT.
say it is open.
Share screen. Stop sharing this, then again share screen. Okay, okay. You can stop sharing the screen and you again share your screen.
Yes, sir. Just
Not the window. Yes. Now you try the next. Yeah, open the PPT. Yes. F5 or in a running mode.
sir,
Yeah, it's
is
okay.
it okay?
Yeah, it's okay, I suppose. Santosh sir, can you
Yes.
see?
Yes, sir. Yes, sir.
Okay.
It's okay.
Okay, thank you so much. Pooja, you can start.
Good afternoon, sir. I'm Pooja Sharma from GLA University, and the topic of my presentation is identification and mapping of urban area using satellite images. Here are some outlines which we will cover in the upcoming slides. The idea of our research is to extract and map the urban area by using satellite data. The data which we are using is multispectral data, having 13 spectral bands. First, we will discuss about remote sensing. What is remote sensing? Remote sensing is the science of obtaining information about objects or areas from a distance. Like we are capturing data of any target object without being in physical contact with it. And we are using the remote sensing here in the context of urban area detection and mapping. Like we are detecting the human-made infrastructure building, and a high population density area. Urban area can vary in size, like from a small town to a metropolitan cities. There are four main components of remote sensing. First is source of energy. Like we need a source of energy for illumination. And the secondary, the energy will interact with the atmospheric phenomena like wind, precipitation, etc. Later, that energy will interact with the target object, and the energy which is reflected back from the target object is recorded by sensors. There are two modes of remote sensing. First is passive sensors, and the second is active sensors. The passive sensor measures the energy that is naturally available to it, and it is useful for measuring vegetation properties. And the active sensor has its own source of energy of illumination, and these are useful for measuring forest structure and precipitation, etc. There are the two types of imagery, optical and SAR. Optical imagery are those which is dependent on sunlight, and these are observed in broad daylight only, and they are affected by weather conditions. We can use this optical imagery in land cover mapping, urban mapping, and environmental monitoring. Examples of these optical imagery are Sentinel-2, Landsat-8, and MODIS. And the second is SAR satellites. These are independent of sunlight, like they can capture in broad daylight and night capacity. These are not affected by the weather condition, like they can penetrate through the clouds, etc. And application areas of these are forestry, marine surveillance, and disaster management. Our objective of this paper is to extract and map the urban area by using satellite data, and to develop a methodology for urban area detection and mapping. Here are some key challenges which we have followed, which we are faced in during the paper, like distinguishing between urban and non-urban land cover can be challenging. Like there are a structure mountain like having a building kind of a structure, and a challenge has been observed that the reflectance of bright bare land resemble that of built up area. Mistaken mapping may lead to inadequate management, especially during a rescue operation to be performed during the disaster. Now we have come to the study area. The study area chosen for the research lies in the northern part of India, a region of Uttarakhand state, Roorkee. We have chosen this area because it contains all the 5 classes: urban area, water, forest, agriculture, and parallel. The data set we are using is we have acquired the data set from European Space Agency, which is Sentinel-2 data set. It has the following properties of spatial resolution of 10, 20, and 60 meters, spectral resolution of 13 bands, temporal resolution of 5 days with 2 satellites, and radiometric resolution of 12 bits. We have followed the methodology of from starting to data acquisition. We have acquired the data from European Space Agency and we sample that data like it has a number of different bands which have the pixel location differently, and later we subset the desired area from the data set and applied some classification algorithms like MD, MLC, RF, SAM, and K-means, and compare the accuracies of these algorithms.
Pooja, please make it fast.
So we have applied some classification algorithm which are we have explored the tool of European Space Agency ESA tool like SAM, medium distance, random forest, MLC, and this is the color bar. Like red color represent the urban area, dark green color represent the forest, and light green color is sparse vegetation, yellow color barren land, and water blue. Like we are here we are using SAM as our base classifier because it classifies all the 5 classes accurately, like barren land, urban area, urban patches जो red colors में, blue line, water line, and the other minimum distance is overestimating the urban patches. And so the SAM shows the best approximate result to the classified area.
Pooja, please make it fast. We are running out of time.
Yes, sir. So we are validating here the SAM classified image. Like as we can see, जो रेड पैचेस जो है वो एक स्पेस के हिसाब से एक प्लेस के हिसाब से सब में क्लासिफाइड है, तो हमने इधर डेटा को वैलिडेट किया है कि जो हमारा सैम क्लासिफाई इमेज जो क्लासिफाई करता है वो एक्यूरेटली कर रहा है. So here are the accuracy results of different ML, different algorithms, which is RF, MLC, MD, and K-mean. Here MLC shows the best approximate result. And the K-mean also shows the accurate result, but it is only depend on the random clustering. So we cannot consider the K-mean here. In the conclusion, like we can say that if we have it has been identified that the bare land patches resemble with the urban patches. Like रेड एंड जो ब्लू लाइंस हैं जो इमेज में है वो येलो पैच में मिक्सअप हो जा रही हैं. अगर हम कोई भी ऐसा कोई सेग्रीगेट करने के लिए तरीका निकालेंगे तो उससे हमारी एक्यूरेसी और इंक्रीज हो सकती है. Therefore, there is a need of an approach to segregate urban patches and bare land patches. This is our conclusion.
Okay, thank you, Ms. Pooja. I just wanted to know from you, why did you choose Sentinel-2, whereas the Sentinel-1, like you said, provides data imagery, satellite imagery, which works at all weather conditions, day and night?
So we have to identify just the urban patches. Like there, if we use the Sentinel-1 data, which is SAR satellite, it will increase the complexity of the code, and we don't need this much of research, I think, for this purpose.
Anyway, what is your plan on approach to follow to segregate the urban area with barren land? What is your plan?
So we can use the deep learning algorithms in the next phase or something, and we can also go for the indices, like we can modify some indices into that.
Okay, Santosh sir, do you have any question?
No, sir. Fine from my side.
Okay, can you proceed?
Yes, sir. Sure.
Okay. Next author is Miss Juhi Shikokar. Are you there? Miss Juhi?
Thank you, sir.
Thank you, Pooja. Miss Juhi, are you there? I suppose Juhi has not logged into the Microsoft Teams. So I request next author, Dr. Harish Chandra Verma, to kindly proceed to the podium and share his views on the topic, an approach to estimate the instability, growth rate, and decomposition analysis of mango crop productivity through Landsat 8 satellite images.
Good afternoon, everybody. My under 64. Shall I start now?
Santosh sir, is it audible and visible?
Yes, sir.
Okay, thank you.
Okay, good afternoon, everybody. Myself, Dr. Hari H.C. Verma. I am working as a senior scientist at ICR Central Institute for Subtropical Horticulture, Lucknow. So my topic is an approach to estimate instability and crop growth rate, as well as decomposition analysis for mango fruit crop using this Landsat 8 satellite images. Next, please. Oh, thank you. So this presentation it contains introduction, study area and satellite images used, methodology, implementation of knowledge-based decision tree, and this result and discussion, and then conclusion. So in introduction, mango is one of the major fruit crop of Uttar Pradesh, and it also well known. It is also known as king of the fruits. And for these horticultural crops are very beneficial crops in all agricultural commodities. Using geographic application to plan horticulture growth and management is efficient, accurate, and cost effective. Applying satellite images can be utilized to monitor the current environment and produce precise prediction about the future. It is necessary to implement a high density planting technique and improve orchardist technical understanding of mango production, increase productivity of mango cultivation, and protect fruit security from natural disaster and insect attack. By using Landsat 8 images of two main mango producing districts of Uttar Pradesh, that is Lucknow and Meerut. This study aimed to estimate the area, production, and productivity of mango crop. It also examined the growth, instability, and decomposition of mango crop area in these two districts of the of Indian state of Uttar Pradesh. Sorry?
जो करवा रहा है कोऑर्डिनेटर उसकी नहीं है। रिपोजिटरी होनी जरूरी है। आपने कोई भी चीज कराई उसको आपको विद इन 5 days आफ्टर सक्सेसफुली कंप्लीशन ऑफ दी एनीथिंग वर्कशॉप और सेमिनार लाइक विद इन 5 days या 1 week आपको एक रिपोजिटरी में इसको डालना पड़ता है कि ये रिपोजिटरी है, इसमें ये स्टूडेंट्स हैं, ये सिग्नेचर्स हैं, ये डेट पे हमने प्रोड्यूस
आशीष सर, आई थिंक योर माइक इज ओपन। आशीष सर,
वो नाम की कोई चीज नहीं, वो होती हर जगह है।
क्या है, कहाँ से डिस्टर्बेंस है कुछ?
वो पॉसिबल नहीं है यहाँ पे, क्योंकि यहाँ का सर्वर अलग है, वहाँ का सर्वर अलग है। यहाँ पर एक सर्वर से काम ही नहीं चला रहा।
Ashish sir, your mic is open. Kindly switch it off. Ashish sir,
हेलो,
your mic is open. Please switch it off.
yes, now start.
So this slide contains study area and satellite data used. So for study area, we have taken 2 districts of Uttar Pradesh, which are mango producing districts, and these are Lucknow as well as Meerut. And geographical boundary of these 2 districts have been given here. And then for satellite data, we have used 16 years of satellite data for Meerut as well as this UP district, Lucknow districts from 2014 to 21 for each district. हर एक डिस्ट्रिक्ट के लिए 8 ईयर का डेटा हमने लिया और 16 ईयर का डेटा हो गया क्लाउड फ्री डेटा फॉर द मंथ ऑफ February and March. So next please. Yeah, yes, sorry, भूल जाता है. In methodologies, it contains Landsat images from 2014 to 2021, and these images has been pre-processed. In pre-processing, raw pixels have been converted to this reflectors images using radiometric calibration, and then this atmospheric correction has been also made under these pre-processing steps. And then using pre-processed data, we have calculated 3 indices. First one is NDVI, second is SAVI, SAVI, and third one is MNDWI, to classify land cover in 7 classes that I will discuss later on. And then this indices has been calculated, and then images have been classified using this decision tree classification method, and then area is computed, calculated, estimated, and after that, once we get the area, and then we have calculated all these 3 parameters, means instability, crop growth rate, and decomposition rate. So this is the decision, this is the knowledge-based decision tree that we have prepared for one other under this project, and it has been reported in another paper that I have given in reference. So it contains 7 classes. First we have separated water using MNDWI, modified, normalized water difference indices, and then second it separates water, and then we have this urban area and this bare soil. 3 classes are these, and then 4 more classes. It contains mango, sparse vegetation, medium vegetation, and dense vegetation. All are classified using SABI. SABI is most effective for classification of mango, as in mango canopy there are gapping. जब mango पेड़ होता है तो उसके बीच में gapping रहती है, and then it has soil brightness has a negative effect on this satellite images. So it cut down the soil brightness from the bad effect of adverse effect of soil brightness has been reduced using the SABI indices. तो इसलिए ये बेटर है इसके लिए क्लासिफिकेशन के लिए. And then accuracy assessment, we have used accuracy using this confusion matrix, and then kappa coefficient and OA overall accuracy has been determined, and after that estimate this mango crop area has been estimated using classified images for each class. For suppose for mango class, AC equal to PC into R square by 10,000. So what is AC? AC is the area for, suppose C is mango crop, mango class. So for mango class, suppose mango class has 5,000 pixels. So PC number of pixels in a particular class multiplied by resolution square divided by 10,000. 10,000 means to convert this meter square to hectare. So this is the formula for calculation of this area, mango crop area. So here 3 more parameters have been calculated using these formulas. First है compound growth rate. Second is instability. Instability is basically, this is opposite to stability. Instability means something is not stable. जैसे हम जब कोई क्रॉप लेते हैं एग्रीकल्चर में, इट इज मेनली डिपेंड ऑन वेदर पैरामीटर. वेदर खराब है तो पूरी क्रॉप प्रॉब्लमेटिक हो जाती है. सो इट बेसिकली डिपेंड ऑन दिस weather. So if weather is not favorable, then if pests and diseases are infecting the crop, then instability will be high. So instability is calculated by coefficient of variation, and formula is CV is equal to sigma by x bar into 100. It is calculated in percent. And third one is decomposition rate. Decomposition analysis. It contains, it provides the effect of different parameters, means effect of area, effect of yield, effect of productivity on this production of mango. So this is the formula. And using a decision tree that I have shown previously, we have classified this. We have first Lucknow district images have been layer, 3 images have been layer stacked, and these images are SABI, DWI, and NDVI. All 3 images have been layer stacked, and then these have been classified using decision tree. So for year 2014 to year 2021. तो इस तरह से इसको किया गया. इसमें आप देखिए different. Red color is urban area, blue is the water body, yellow is bare soil, green, there are 3 green, one is turquoise color, this is sparse vegetation, and light green, and then deep green. Light green is for mango vegetation, and deep green is for dense vegetation. So accuracy assessment, we have used 125 ground truth samples to assess the this accuracy.
Please conclude it, sir.
Okay. So in this case, we have found that overall accuracy ranges from 68 to 86%. Kappa coefficient is more than 0.60 in this case. So similarly, once this mango area has been projected, then we have determined. Actually, government has reported the mango area and production till 2016 for the UP, not UP, for all states of India. So our purpose was to do this this analysis till 21. So for 4 year data, we have used moving average for the calculation of area, projection of area, and for production we have used area as dependent variable and production as independent variable. Area as independent variable and projection as dependent variable, and we have determined the production of mango crop. So it has been projected, and then similarly for this, I am not going to explain this. This is classified images of Meerut district, and same process has been applied for accuracy assessment and area estimation. And then this is classified images, means area projected by this DTC for Meerut and Lucknow district. Here in table 2, it can be seen that mango crop area is fluctuating during 2013-14 to 2020-21, and production is also changing with change in area. तो area production दोनों fluctuate हो रहे हैं इस period में. Similarly, according to statistic provided in figure 4, आगे है figure 4. It can be shown that both districts mango crop area and production marginally increased during 13-14 to 2021 period. And according to the findings, both districts mango fruit crop output and acreage exhibit sign of instability and CGR. Additionally, the comprehensive investigation of mango crop area is conducted.
Please make it fast.
Okay.
Please.
So here in this case, it was discovered that throughout 8-year period, that is 14 to 21, Meerut district has most variability is 6.39% as well as lower CGR 2.59. Yes. So this is area and production of Lucknow and Meerut district. So this is this graph for production of this both districts comparative graph, and then in this case the result and discussion. The productivity of mango is calculated for both districts using data on crop production and area that is presented in jointly in figure 5. नीचे दिया गया फिगर. तो ये हो गया हमारा क्रॉप एरिया एंड प्रोडक्शन का
Okay, sir.
projection. And then information that CGR is stability of mango area production in Lucknow and Meerut is shown in table 3. This is CGR and CGR and instability for this area as well as production. दोनों के लिए अलग-अलग है. Lucknow district as well as Meerut district.
Okay, sir. Please conclude.
हो गया, I think ये last है.
Please conclude it.
Okay. District wise, चलो ठीक है करते हैं. Conclusion. To track the instability and growth rate of mango crop area and production in Uttar Pradesh district of Lucknow and Meerut, a critical analysis has been conducted in this paper. Following the thorough investigation, it was found that Meerut district has highest variability of 6.39 in the mango crop area and from 2013-14 to 2021, with CGIR of 2.53. In comparison to Lucknow district, the Meerut also demonstrate greater instability in the mango crop acreage and productivity. In the future, government agencies and policymakers may find this study to be very helpful when planning area expansion. It is quite obvious that the adverse climate effect and other factors of mango production affect productivity. Therefore, it can be concluded that both district mango production can be increased by increasing the area. It has been found that production is exactly dependent on the area, so production can be increased by increasing the area. Thank you.
Welcome. Thank you very much, Dr. Verma. It is indeed good work. Here, just a quick question to you. Okay. How many images have you used each year from 14 to 21?
16. For each district, 8 images.
Okay. How will you validate the estimation and address the instability? If for example, if you have estimated the areas, but how do you validate it?
We have validated this area and crop production data that has been derived by this satellite images, but for validation of this instability, there is no method available.
Okay. Santosh sir, are you there?
Hello.
Do you have any question to ask?
Yeah, actually, I have some questions regarding prediction. What method he used?
Sorry.
What method you have used?
What method you used? Yeah.
Method.
Yeah.
For
Which
what?
method? On which method you used?
He is asking for methodology.
Methodology तुमने अभी बताया सब.
Which method is you have used?
I have told for classification we have used decision tree classification, and for
why decision tree?
Dysentery is it is very good.
Actually, you
We
can
have
use also logistic regression. Then why you use dysentery?
So we have done, we have used all the methods that are available in ENVI software. That is ANN, SBM, and other this supervised and non-supervised methods. But we found that this decision tree is more flexible as well as it provides more better accuracy. So we have used this. We have another paper that has been given in reference. So it can be seen that we have compared all the methods, and decision tree has given more better accuracy. So we have utilized decision tree for yeah, implemented decision tree for different districts classification of images.
Okay.
Okay, Santosh sir, thank you so much. Thank you, Harish sir, for your views. And next, I would call upon Miss Soumya Singh. Her paper title is Classification of Health Status for Sugarcane Image Using Machine Learning. Her paper ID is 194. Soumya Singh, are you there?
Yes, sir. Can you hear me? Sir, can you hear me?
Yes, yes, you are audible.
Good evening, sir. And good evening, ma'am.
You can share your
Sir, yes, sir. Is my screen is audible? Seeable?
You are audible, but your skin is not visible.
Just a minute, sir.
Just click on the share button. You can share your entire window.
It's not working. Just a minute, sir.
Soumya, please make it fast.
Sir, my mouse is not working.
You can do one thing, you can log it out and you can log in again from Microsoft Teams. We'll join you.
Okay, sir.
We'll join you after 10 minutes and we'll take up a next presentation. Okay?
Okay, sir. Okay.
Okay, so next is Mr. Ashish Kumar. Ashish, are you there?
Yes, I'm there.
Okay, we are having a Mr. Ashish Kumar. His presentation title is Enhanced Crop Diversity Assessment Using Hyperspectral Data, a Spectrum Characteristics Method. His paper ID is 257. Ashish, you can share your screen.
Yes, I'm sharing. Is it visible?
Yes, it is visible.
Okay. May I start?
Yes, yes, you can start.
Okay, a very good afternoon to all session chair and session coordinator and all the presenter and attendees. My name is Ashish Kaur and I am a research scholar in Department of Civil Engineering, IIT Roorkee. And my presentation title is Enhanced Crop Diversity Assessment Using Hyperspectral Data, a Spectrum Characteristic Method. And these are the outlines of my presentation: introduction, study area and data use, methodology and implementation, result and discussion, conclusion and references. And now, in the introduction, crop classification is an important and an essential task for the researchers in nowadays. So the researchers and scientists have been utilized the airborne imagery, multispectral and hyperspectral remote sensing data for the crop classification from last 1 or 2 decades. And the use of hyperspectral dataset provide the spectral information captured across numerous narrow bands of to distinguish between the different crop types, and HSI allowing for precise identification and monitoring of crops. So hyperspectral data enables the detection of suitable spectral differences, improving accuracy in crop classification and health assessment. So in this paper, crop diversity assessment has been done using hyperspectral data based on a spectrum characteristics method. So this is the study area and data used for this study. In this AVRS sensor, Indian pines dataset has been used, which have the 224 bands. And after correcting the bands, we have got the 220 bands. So the data, each channel has the 145 into 145 size pixels in each challenge. And we have, as you can see in the figure 1A, there is a, this is the RGB image of the data set, and the ground figure 1B is the ground truth for the Indian pine data sets. This is the methodology and workflow of my implementation. In this, after preprocessing the hyperspectral data set, the preprocessed hyperspectral data set is uh, uh, enter into the spectral character. After that, the preprocessed data set, we have formed the spectral characteristic feature sets, in which there are 4 parts, making the data cubes of some visible NIR or SWIR bands, and biospectral ensemble, morphological features, and the RGB bands. And after that, layer stacks of these spectrum characteristic and feature sets has been done. And after that, removal of salt and pepper noise has been by using the median and Wiener filter applied. And after that, dust boost applied classified to the after getting the median and Wiener filters output. So the spectrum characteristic set formation, in the spectrum characteristic set formation, the spectrum characteristic set includes the spectral data cubes, the biospectral ensemble, morphological characteristics, and the red, green, blue bands. For creating the data cubes, we have divided the data into the based on the wavelength 400 to 700 micrometer, which is the visible region, and in which we have 34 number of bands. And second one is 700 to 1000 micrometer, which is the near infrared region, and in which we have 30 bands. And after that, 1000 to 2500 micrometer, in which we have 156 number of bands, which is called the SWIR, short wave infrared region. After that, as you can see in the figure, after that, dimensional reduction techniques, which is called PCA, has been applied to 3 data cubes, and we got the we have taken the first 2 components of each data cubes. After that, some biospectral ensemble has been formed from the input data. 19 indices of biospectral information has been derived, as you can see in the table. These indices include the information on vegetation content, nitrogen content, water content, and light use efficiency and dry carbon content. These are the 19 biospectral indices. After that, morphological features has been derived from the data, and 4 different morphological profiles has been used in this work. And then the visible region 400 to 700 has been divided into 3 parts, which is based on 625 to 700 micrometer, which is called the red region, and the 500 to 565, which is called the green region, and the blue region is 450 to 489. As you can see in the figure, the same dimensional reduction technique PCA has been applied to these red region, green region, and the blue region, and the our first component of each output has been taken for the further processing.
Ashish, your screen is not visible.
Just give me share it again. Is it visible, sir?
Yes.
Okay. Then the formation of layer stack of spectrum features has been formed, in which we have 32 feature sets. Once spectrum characteristic set has been created, then they are all integrated into a layer stack. Then this layer stack is composed of 32 features, 19 from the bispectral ensemble, 4 from the morphological features, and 3 from the RGB bands, and 2 sets of features from the visible region, near infrared region, and short wave infrared region data cubes. So after that, some median and winner filter has been applied. Median filter is a non-linear filter method for removing the noise, especially salt and pepper noise, which is caused by some pixel having the excessive values. And the winner filter was applied to reduce the mean square error between the estimated and true signals. It is effective to mitigate the Gaussian noise, basically. After that, Rust classifier has been applied to the result to the data for obtaining the classification results. And the RustBoost is a combination of random undersampling and AdaBoost. The problem of class imbalance in data with discrete class labels is intended to be addressed by the RustBoost approaches. So by limiting the sample from the majority classes, it combines the usual boosting processes. This is the resultant discussion slides, and the proposed model have the 96.78% accuracy. To analyze the significance of derived feature sets of 32 features over original 200 hyperspectral bands, the RustBoost algorithm was applied on 2 other feature sets. The first feature set is consisting of 200 original bands, which were denoised and further assembled for classification using RustBoost. The original band set produced a maximum accuracy of 78.16%. And in the second feature set, composed of 32 bands obtained by applying the dimensional reduction technique, which is PCA, to the original 200 bands by using the PCA, and it yields the overall accuracy of 82.110%. As you can see in the figure, the green line, the red line is the accuracy on original bands, and the green line is the accuracy of after PCA applying first 32 components of PCA, and the blue line shows the proposed model accuracy. Now, after applying the RustBoost classifier to the original data set, the results are shown in the in figure 4A. The results of the RustBoost classifier applied to the dimensionally reduced data set of 32 bands is shown figure 4B, and the proposed model figure is shown in 4C. As you can see in the figures, the proposed model figure is better visual as compared to the other two. In the conclusion, in this study, spectrum characteristic feature sets based on the crop classification model has been proposed using hyperspectral data. In this model, bioensemble feature sets, morphological feature sets, reduced spectral bands were evaluated by applying the RustBoost classifier. The RustBoost classifier has shown a satisfactory accuracy of 96.79% due to its ability to handle the imbalanced data and boosting nature. The obtained results were compared by applying the RustBoost directly on the original data sets and by applying RustBoost on reduced 32 bands obtained after the principal component analysis dimensionality reduction techniques on the original data sets. The direct application of RustBoost on the filtered original data achieved a maximum accuracy of 78.16, and applying PCA to reduce the data set to the top 32 principal components before RustBoost resulted in is an improved 82.10 maximum. As so, our proposed model gives the better accuracy as compared to the other. So these are the references. Thank you.
Okay, Santosh sir, do you have any question to ask?
Yes, sir, I have.
Yes.
Can you go to the first slide, Ashish?
Ashish sir?
First slide, sir.
Yes, yes. Can I have your topic?
So this one.
So, first of all, first question is that you talk about the data set. From where you get the data set?
So it's freely available on the website of a university, Purdue University.
Which university?
Sir, it's a PRUD. It's freely available on the websites of university. US universities. University is based on US.
So you work on a predefined data set. So how can you say that your model is so accurate? Have you
Pardon, sir?
did the comparative study? So my question is that
Yes, sir. I
when
have.
you work on a predefined data set which is already existing, then how can you say that your model is very good or accurate?
Sir, I have compared my model based with the two features, two different to drive the two feature
No,
sets also. As you can see,
you haven't work on real data. Actually, you work on already set data. So this data
yes,
can
yes,
give
yes.
already same results, same accuracy. So where is your data set?
Sir, yeah, it's a freely available data set I have taken,
No,
and
no, it's okay.
whichever model I have applied, and
Actually,
which
actually, I
this was
want to
complete.
know that
Sir,
if you work with a predefined data set, then there is no accuracy comparison. Actually, it always give you accurate answer, so much accuracy. So you cannot say that your model is very much accurate. And second question
sir,
is that which algorithm you used?
which algorithm
Have you
I use
have you
for?
designed your algorithm?
Sir, I have designed a model. This is my model.
You designed a model, but you use a word said you algorithm. So you said in your
No, no,
presentation that you use an algorithm that gives you accuracy. So which algorithm you use to find the accuracy?
sir, sir, I have not used any of algorithm. I have just modeled.
Okay, that's
I have
okay.
used my
Now
model.
now tell me the third
Uh,
one and what tool you used.
yes.
On which tool you have worked?
What?
Which
Okay,
tool
MATLAB.
you used? MATLAB for you
MATLAB
use
for
MATLAB for
data preprocessing.
simulation.
Sir, all the things which I have shown in the figure done in the MATLAB only by
You did
coding and
MATLAB.
by taking some functionality, etc.
Okay, one more thing. You use RUS boost. Okay.
Yes,
Why you haven't
yes,
used
sir.
X boost, XG boost, and ADA boost? What is
Sir,
wrong in that
actually,
model?
are you Rust boost basically is the combination of ADA boost and the random undersampling. That's why, and it is tackle the class imbalance data, which is a discrete class level in the intended to address. That's why I have used the Rust boost classifier, not the XBoot and ADA boost.
Okay, thank you. All of That's all from my side. Uh, Sir, if you want to ask, then you can ask.
Okay, sir. Thank you so much, sir. Thank you, Ashish, for your views. And now
Thank you,
I
sir.
request Miss Soumya Singh to again re-log in and share your screen. Soumya, Soumya Singh. Miss Prerna Sahu, are you there?
Yes, sir, I'm here.
Okay, let's take up your presentation. And we're having another author, Miss Prerna Sahu. Her paper title is High Definition Thermal Imager Range Modeling and Analysis for Aerial Targets. Her paper ID is 280. Prerna Sahu, please share your screen.
Yes, sir, I'm sharing.
Sir, is it visible?
Yeah, it's visible, but
Sir, is it visible?
yeah, it's visible, but make it a running time. Press F5.
So
Press
now,
press F5 or running
sir, ma'am,
mode. Correct.
so, shall I start?
Uh, yes, you can start.
Good afternoon, everyone. My name is Prerna Sahu, and I'm working as a JRF in IRD DRDO. So I am here to share insights and learning about high definition thermal imager, range modeling, and analysis for aerial targets. So the content I'll be having introduction, the proposed model, the result discussion parts, and the conclusion. So basically, as we know, thermal imaging plays a crucial role in the threat identification for military aviation and facilities aircraft health monitoring in civil aviation. So here in the primary objectives of this research is to furnish user with reliable information what to anticipate during field excursion. In this study, we have implemented the NV-thumb model for detection, recognition, and identification calculation for various aerial targets based on different categories. So the categories can be depends upon different speeds and different dimensions, aiming to provide accurate range prediction in specific field settings. So the methodology employed by the thermal imager to assess its operational capabilities across varying environmental conditions. Here for environmental condition, we can have different temperature, relative humidity, encompassing factors like weather patterns, temperature fluctuation, and humidity levels. The thermal imager relies on advanced software algorithm for this calculation, which are crucial in determining its effective operational range. Additionally, the paper provides a comprehensive overview for the fundamental principle and functionalities of thermal imaging technology, starting from its initial design phase and encompassing its evolution and key operational characteristics. So the proposed model I am having, the NV thumb has been
Your
significant. Yes,
Prerna,
sir. Yes, sir.
your slide is not moving.
Wait, sir, is it now visible?
It is visible, but can you press F5?
Sir, I'm pressing F5. Is it fine? Now is it moving?
Yeah, it's moving, but
Right now I'm in proposed model page. Is it visible?
yeah, it's visible.
Yes, sir. So NVTherm has been significantly updated by replacing the Johnson matrix with the target task performance matrix. So for detailed information on calculation, users should refer to the target task performance matrix, which is basically a new model for predicting target acquisition performance. Basically, what is TTP matrix, which aims to quantify and predict how well an individual or system can acquire and identify target in various scenarios, which is crucial for application like military operation and automated system. So basically, target task performance components contains of detection, classification, and its response time. Now, target task performance based on the application of Johnson criteria, all computer models deal with the human observer model that is simplified and isolated target with continuous target contrast. Better resolution is possible of the thermal imager technology, which produce image sensor that are more sensitive. Using Barton human vision model to introduce more precise human vision modeling was the initial steps towards modeling advancement. The target task probability approach second stage involved figuring out the likelihood of a certain target acquisition task. So this is the result and discussion part. Basically, for this, I have taken various input which are based on the optical parameters, which consist of a field of view, instantaneous field of view, accuracy, scanning times, and also I'm having the detector details, that is detectors format, what is the
array type and the spectral band. Here I have used the MWIR. And now I have also considered the target details, which consist of its dimension, its speed, and the environmental condition. Here I have used the tropical model. So by graph, we can see that the figure 5, I'm having the aerial target 1, 2, 3, 4, 5. The first aerial target, the detection is on 14 kilometer, because the target size is small and the speed is also low. And
to interrupt, Prema, can you
yes,
can you scroll the slides because it's not moving now?
uh, so the result and discussion part is visible.
Stuck to your first slide itself. So can you scroll it down?
Yes, sir. First slide. So this
Uh,
one.
Soumya Singh?
So I'm Prerna Sahu.
Yeah, you are Prerna Sahu, but Soumya Singh is sharing the screen. Soumya Singh? Soumya, please stop sharing your screen. Prerna, you can carry on, please.
Yes, sir.
Once again, share your screen, please.
So is it visible?
No.
Okay. I'll share one more time. So wait. Is it visible?
Yes, please carry on.
So basically, I have taken various parameters for this, which can be dependent on the optical parameters, which is basically the optics, the detectors details, which can be the array type, what the spectral band I have used, and the target and its environment. So we can see aerial target 1 to aerial target 5. We have different size and the different speed of this target. So the first one is detection, recognition, and identification for different aerial targets, which we are assuming, which is 1 kilometer in altitude from mean sea level, and this is the for 80% of probability. And the second one is for when the target height is 2 kilometers of altitude from mean sea level, and this is basically with the 80% of probability. So what is this? We have got for lower F number, we get improved detection, but for higher F number, we are able to identify, or we can specify which type of target it is. And for the smaller focal length, we can cover a wider area, or we can say we can have a very wide field of view. For smaller pitch, when we are using a smaller pixel pitch, it will enhance the detection. We will have more clarity. But when we talk about a larger pixel size, then we are able to specify, or we can say the sharpness of the image gets improved. Wider field of view enhance detection. Narrow field of view is used for the recognition and identification. So basically, when we talk about wider field of view detection, we know there is something we are having as a target, and then for narrow field of view, it will recognize the target will come in which category, and then in identification part, we can identify which type of target it is. If it is aerial target or it is a drone type, so which type of a drone we can identify. Now, so we can see higher transmission rate also improve detection, recognition, and identification. So for when we have a higher atmospheric transmittance, which vary from 0 to 1, if we are having 90% or 80%, then the detection, recognition, and identification is more clear. Now for the conclusion, but the rain analysis considers several factors, including atmospheric condition like temperature and humidity. Higher temperature and relative humidity were found to reduce performance, while larger target size improved detection, recognition, and identification at greater distance. Reflectivity and emissivity also played a crucial role. Higher reflectivity provides stronger and clearer signal to the sensor, and high emissivity improves thermal imaging by emitting more infrared radiation. However, higher target speed reduces detection reliability and blurred imaging data, complicating recognition and identification. And the overall analysis was based on the 80% of probability. Thank you.
Yeah, thank you very much, Prerna. Okay, what do you conclude in the end? What do you prefer and what do you suggest from the research you have carried on?
So basically, we can say if the main concern is for only the detection of the target, if you don't want to know the target is a drone type or something, so then we can use the F number. We can take less, which can be 2, 3, and anything something else. But if we when we are concerned more about which type of target is it? Is it drone type or it is any helicopter or anything? So we have to increase the F numbers. We have to work on the optics, and basically, uh, if we are you're doing this analysis for larger length, like up to 100 kilometers, then the atmospheric factor is also important. We want also the atmospheric transmittance should be high. So basically, it depends on various factors like which type of detector we use, what are the parameter we have to select, which type of optics we should select for the use of our analysis.
Okay, okay. Thank you so much for your time.
Thank you so
And
much,
next,
sir.
Miss Soumya Singh, are you there?
Yes,
Soumya
sir.
Singh, are you there?
Yes, sir.
Yeah, you can share your screen. Here we are having another author, Miss Soumya Singh. Her paper title is Classification of Health Status for Sugarcane Image Using Machine Learning. Her paper ID is 194. Soumya, please share your screen.
My screen is visible, sir.
Not yet. Yeah, open it.
My screen is visible.
No. Your PPT is not visible. Open it. Open it. Yeah, you have to share the screen.
Sir, I already shared.
Okay, okay. You can open the file, the PPT file.
Sir, I'm the second page.
Yeah, you are not visible. Your PPT, yeah.
Ms. Soumya, you need to stop sharing the screen, click share again, afresh, but choose screen this time, not window.
Now, sir.
No. You do one thing, log it out and log in again.
Sir,
Log
I
it.
did it several times.
Yeah, yeah, I know. I know. But still you are not visible, na? Your PPT is not visible.
My screen is shared from my side.
Do one thing, log in again. RS sir, please. ये last है. Next, we are having another speaker, Mr. Muhammad Arif Ali Usmani. Yes, Soumya. You can share your screen.
Now, sir?
Yeah, it's okay now.
Oh, my God. So my title is Classification of Health Status for Sugarcane Image Using Machine Learning. This is my content related to my project. And this is the abstract. Basically, here I'm collecting some images of sugarcane with there are several diseases and one healthy class and tested the leaves of sugarcane is healthy or not. This is the basic idea of my project. This is the introduction why I choose sugarcane and why it is important for our economic. Here, sugarcane is an important cash crop or commercial crop. As we also know, it is important from the Vedic period, from 1500 BC. And UP, Maharashtra are the major states who produce it a huge amount. It also comes in a primary activity and about 20% of GDP come from it. This is the literature review, sugarcane diseases recognition using deep learning and sugarcane model using detection model using different in like RCNN, SSD, ANN, CNN. These are the techniques. This is the research gap. Less quantity images are used to get. Hello.
Hello.
Hello. Your screen is gone, Soumya. Hello, Soumya. Can you hear us?
Soumya? Arif sir, carry on. Santosh sir, are you there?
Hello.
Yes, sir. Only one presentation is left, sir.
Yes, sir. Actually, some network issue is there. That's why
Yeah.
I was not there.
Yeah.
Now I am connected.
No issue, sir. No issue.
Okay.
आपका ये है ना? ठीक है।
Most Hello, Honorable Dr. Santosh Kumar, Honorable Mr. Dr. Mohammad Sadi sir, and Dr. Ayan sir, and Razia ma'am, and my dear all colleagues. My paper, I'm Mohammad Arif Lusmani. I'm working as an assistant professor in Department of Computer Science for Computer Application in the Integral University Lucknow. And my topic is an approach to detect a nitrogen deficiencies of paddy crop on agriculture farm using digital image processing. What दे रही? आगे बढ़ा रहा है. My content, introduction, methods, purpose, model, and result discussion and conclusion. Introduction. Nowadays, problem growing populations and stationary or land have decreased per capita agriculture productivity. And second, predicted need for 20 to 70% more gain in the futures. In 20 years, over 9 million peoples, 900 million peoples will need large amount of nitrogen fertilizers. This problem's solutions for I choose leaf color chart LCC techniques provides for nutrients information for leaf color charts. कर रहा है कभी नहीं कर रहा है. Mm. The today's three types of technologies available on the these techniques, and first soil test, and second is pad meter, and third LCC chart. So then I choose LCC chart for the detect nitrogen in pod crop. पढ़ नहीं रहा इससे आगे. होगा सर इससे. The choose the nitrogen deficiencies color chart or a leaf collect from the forms, and to convert slides in this way and compare with a normal normal leaf, and to convert also leaf color chart, and this comparison to two approach, and KNN and SVM support vector algorithm, and KNN nearest neighbor nearest neighbor algorithm for the pixel detection. The choose by satellite and mobile phone, choose pictures, collect and process in digital image processing. Then apply machine learning, support vector algorithm, and KNN approach. Then the processing, then the chart group, the framework is ready, and the detect this leaf color chart for by the slides, and my result is 35 kg per hectare needs for this color. Okay, and graphical representation, yield based nitrogen required. Next. Uh, the result and decisions, our innovative soil testing technology addresses the limitations of both traditional and modern method, transforming current practice using leaf color chart methods. It provides an economical and efficient alternative, labor incentive, and costly on-site soil sampling for assets planning plants nitrogen deficiency, because this is free of the cost, and but soil test 9 lakh rupees expense per hectare, and SPAD meter also start thing range 3.5 lakhs to 12 lakhs 12.5 lakhs per meter. The Kisan is a very poor personality. They will not bear this, but this is a free from the. Okay. Identification, leaf color chart picks two types of technology available. First, to generate pixels in matrix form, when pie chart, numpy in the Python, and this color based determination or matrix algorithm in digital image processing analysis with CV2 also import in the Python. And second,
So thanks to slide is shown here.
leaf color chart to change in RGB code. And RGB code is, but there's a never, because appropriate result we achieve in mathematical metric method in the digital image processing. But it's a 19 approximate result detect.
Santosh sir, do you have any question? Santosh sir? Santosh sir? Okay, sir. Thank you.
Okay,
so
sir.
much.
Thank you very much, and thank you to all.
सारा सामान मेरा है। ये आपका सामान है।